is they've said, what if the user wants to give a list of amino acids for which we need to calculate the percentage of amino acids that amino acids make up of in the protein. What do you do then? It's given us a new set of assertion functions, and remember again, my assertion functions all were replaced with assert and your function name over here that you've defined it as. You can't use the my function here. This is just them showing you what to do. So you would copy this exactly as is, and you would add your function name to the front. So again, the body of the code is this over here, with the exception that we would normally put this line also on top. So if you view it from that point of view, then your function would initially look like that. This would all not be there. It would just be this part. Actually, not the return also, just that. And normally you would maybe do, you would have, instead of return over there, you would have print. So this is exactly how you would write your function before you put it into all of this. You would write it like that, and only afterwards would you then only afterward would you then make sure that this is following the proper syntax. Okay, so here we are now at the point where we are savvy. So one of two things. The function is almost exactly the same, except for the fact that here, instead of taking an amino acid, one amino acid, it's taking in a list. And we did lists last week, where we saw lists are usually in square brackets, and all the items in the lists are separated by commas. Okay, so here we've got a list, and they've given a list name. Because, and the reason why they do it this way, so normally, if you didn't have it like that, if you didn't give a default, then you would have written the function like this with an empty list, right? So the person would have to put in a list there, a list of values, and they would be forced to put in a list of values. If they don't, the system will give an error. But we've designed it in the same way that we did with the significant figures, where we've put a default list in here, which they've given us. They've given us a list of hydrophobic amino acid residues, so that in case the person uses the function and forgets to put in this, it will just automatically calculate the percentage of hydrophobic amino acids in the protein sequence that they're giving us. Now remember, they're not giving this by default either, because that will really just be that won't be a function. It will just be senseless, because we're giving the user everything. We're giving the user something the user's not asking for. Okay. So yeah, again, we always said was we convert the protein sequence that the user's giving us to .upper, and we do the usual, we calculate the length of the protein, because we know that we're going to use this. Okay. And then we're going to have to use the for loop that we learned about last time. So the for loop is going to go and look again, they're starting with total is equal to 0, because we are going to have this as a holding place that has nothing in it, but so that we can add the amino acids every time we go around this list, or the list the client is given, the user is giving. We can increment this and say, okay, I found A once, I'm going to store 1 in there. If A occurs again, then I'm going to add it to this, and it's going to be there twice. So this is just so that we have something to hold a value in, because we're going to keep adding how many times a specific amino acid is found. So it then says for amino acid in amino acid list, which is again what the user will give. We convert the amino acid to that upper, just to be safe. And then we do exactly the same. We're going to count it. And every time it finds that in there, it's going to add it to this total over here. So the first time around, it's going to add it, and so it goes on. Every time it finds it, it's going to add up that amino acid, and then it's going to print the total, the percentage, because we tell it to, and return the percentage for that. So here we're giving it the amino acid. I'm ignoring this because, again, this is exactly the same as what we did. It's calculating these percentages, and they've made sure that these calculations are correct. So the user gives a protein sequence, and for this protein sequence, the user wants to calculate the percentage of R and P, where P here is in a small letter, and we've made sure that you can find a P if it's in caps as well. We then call the function with a protein sequence, which is this, and we give it the list, which is that, and it should be able to calculate the amino acids for us. Now, I just want to show you, this is like the body of the loop, so that you can see what is happening as it's going around. This is before it's printing this part. You can see that it's going around the list, and it's looking for A, and it's not finding A, so it's recording 0. It goes and it says, let's do it over here, for amino acid in amino acid list. So it goes, okay, what's the amino acid list? Okay, it's this one over here. And then it's going converted to dot upper. So it goes, okay, I'm in A. I'm going to convert A to dot upper. Then it goes, count the number of times A is in there, and it goes, oh, it's not in there. I'm going to hold. The first time around, it goes around, it holds a 0 value. And then it goes and it puts it in here, right? So total is 0, but the amino acid count is also 0 because A is not in there. So the first time around, total is going to be 0 plus 0. Then it goes, okay, I'm not done with this loop because there's still a lot of values in this list. So I need to go to the next one, and it goes, for, I've done A, I'm on I now. For I in amino acid, or for I in this list, or the second item in this list, convert that I to upper, and then count how many times I is in here. Okay, it's counting I because I is in amino acid. And then it sees, okay, I is there also 0 times, so it holds 0. And so it goes on, then it goes to L, and it sees, okay, counts the number of times L is in there, and it holds it. So now, when it goes around, it's 0 plus 0 plus 10, because it's there 10 times. No, yes. And it holds that value, and so it goes on around the list, and it keeps adding because we want it for the entire list. And then afterwards it prints for this batch that you wanted. It's in that thing 13%. It constitutes 13% of this amino acid list. And then, or 13 of it is in the amino acid list. And then it will divide that 13 by the length and calculate the percentage for that, and then you get the 25 out. Okay, I can't remember how long. 13 divided by, was it 20 or something? Anyway, so that's just to show you what's going on in the loop of your function. And that's about it. The book itself understands that functions can be a bit tricky. So they only gave those 2 exercises. But functions are really something, you might not use it that often, but it is something useful for if your code becomes very complex, and also for you to be able to read other people's code or functions, because sometimes you don't want to reinvent the wheel and write all your code from scratch. But if you're going to use other people's code, you're going to have to be able to read and understand what the code is doing. So don't get a fright now when you see assert, because you know what it's doing. Don't get a fright when you see def, or when you see default values in here. because now all of that is, so even if you never write functions, you should be able to at least read what the function is doing now, because a lot of these words are no longer unfamiliar to you.